Welcome. Let's do this. You're probably as happy as I am to finish the packet 58, 59, be careful, 58, 59, and 60. We've finally done 60 questions, and as I told you, every time I do about 20, I got some sticky ones. So this one's pretty sticky. This one's a little weird. This one's pretty straightforward. Your answer should be E for 58, E for 59, and C for 60. So let's dive in. Let me just circle that really quickly. Again, E, C, and E. Let's take a look. 58 says some physicians did a study at a large medical experiment involving 22,000 male physicians. They are attempting to determine whether or not aspirin could help prevent a heart attack. In this study, one group of about 11,000 physicians took an aspirin, while the other in a control group took a placebo, which means a pill we know does nothing, but the doctors don't know that it does nothing. This allows us to tell cause and effect. So, after several years, it was determined that the physicians in the group that took aspirin were significantly fewer heart attacks. So if we do a study and we find that the difference is significant enough, then we can say that taking an aspirin every day is suggested. However, there's some problems here. So the question says, which of the following statements explains why it would not be appropriate, so I'm going to really mark that up, would not be appropriate to say that everyone. Now, we've said the whole class, nobody gets to say everyone. And this is the basic idea of inference. So if I study everyone at Boca Ciega High School, and I can take a sample of 100 people in Boca Ciega High School, all I can do is make an inference about people in Boca Ciega High School because that's my population. So I can take a sample, but the only thing I took a sample of are males. So that's item 2. Because there's only males, I could not make an inference about everyone. So right off the bat, item 2 would be one of the reasons why it would not be appropriate. The other thing I noticed is I studied only physicians. So I would not be able to make an inference about things that are not, or people that are not physicians. And so 1 and 2 are already going to go out. And the only one that groups 1 and 2 is E. So I'm pretty positive about E, but let's take another look about that one. Number 3 says, although taking aspirin may be helpful in preventing heart attacks, it may be harmful in other aspects. Again, we're thinking about this everyone. So maybe people in a different profession, it would actually harm them based on what they're doing. I have no idea why it would harm someone, but maybe their profession is a food critic. So they're eating a lot of foods. Maybe part of their job is to eat a lot of foods, and maybe someone who eats a lot of different foods, it would be a really bad idea. We don't know, but based on our process of elimination, we're feeling like E is the best answer. Now let's go to our probabilities question. It is a doozy. Let's dive right in. Question 59 and 60 says, every Thursday, Matt and Dave have a roll the dice day. This is a classic probability question. The customer can choose to roll 2 dice. So here's my 2 dice. So if I get this, I would pay 65 cents. Well, no, I can't read upside down. 54 cents. Roll again. I'm going to pay 21 cents for that second video. Roll again. I'm going to pay 64 cents. And so they're just explaining that if you roll 2 dice, they just pick the higher number, and then that would be 41 cents is what you pay for that second video. But you guys don't even know what a video, this would be like at a video store. So this question's from a really long time ago. But just imagine upload a second video off of Apple Tunes or something. You get the point. A second video, super cheap. So they tell us the expected mu is 47 cents. And that makes sense. Even though that we don't have a dice that's 7, on average, all the numbers we got did tend to be anywhere from, the lowest would be 11 cents and the highest would be 66 cents. So we kind of know our range is 11 cents. That would be the cheapest you'd get that second video, all the way up to 66 cents. And so it should make sense if some crazy mathematician calculated those probabilities that the average would be somewhere 47 cents, and they calculated the standard deviation of that at 15 cents. So every customer that comes in, if you were the proprietor of the business, you would expect to lose about 47 cents plus or minus 15 cents. And that's it. And then they asked us to calculate, well, what if a person came in 20 times? So that's this idea. I use this formula a lot. NP. So what's the number of times times the probability of it happening? And what is the probability? That's your expected value. So 20 times 0.47, and I get $9.40. And that's exactly my answer. So I'm like, yeah, that's what I would expect. Now on to here. I want to just do the exact same thing there with my standard deviation, and that goes back to transformation. So we have to understand that when we transform the numbers, the mean, like if I gave everybody extra shoes that made them this much taller, that would change the mean by this much, but it wouldn't change the standard deviation. Everybody would still be plus or minus 3 inches because everyone put platform shoes on and we're that much taller. So we have to always remember, and even I forget, that we can only add variances. Only add variances. Only add variances. We can only add variances. So one guy comes into the video store one time, and then a second time, and then a third time, and then a fourth time. Let's see if we can calculate just the first and the second time. Still, we can just multiply. So if he came in 2 times, we would expect each time he came in to pay around 47 cents. So if he came in 2 times, we just multiply. It's real easy. 47 cents times 2, we'd expect he'd spend 94 cents between those 2 visits. That's not the variance. So we can't just say that the standard deviation is 15 cents and just multiply that by 2, because we can't do that. We got to do variances. So the standard deviation is 0.15. And that's the standard deviation. So we're going to find the variance. So I'm going to square both sides, and voila, we found the variance. Not a big deal. But that's only in the variance of one visit. So when I take 0.15 squared, I find that the variance is 0.0225. So I'm now recognizing that that's the number that I can calculate. So this plus this plus this plus this plus this, 30 times coming in. I can add variances. I can only add variances, and that's all I'm going to do. And if I add a number 30 times by itself, that is multiply. So yes, I can multiply, but I was really adding. So that number times 30, it's already in my calculator, so I'm just going to multiply that times 30, because now that says 30 visits. And so now be careful, this is my variance. My variance is 0.675. So my variance of all my 30 visits is this. And so to find out the standard deviation of the 30 visits, then I've got to take the square root of that. So I got to be really careful. I'm going to take the square root, and that's going to give me the standard deviation of all 30 visits. And I'm just going to put a subscript there of 30. So my standard deviation of all 30 visits was 0.675 because I took 0.5 squared. So now I have my variance. And when I had that number, I multiplied it by 30. But that's the variance of 30 visits. So to square root both sides, it's still in my calculator. So when I square it, the standard deviation of 30 visits is 0.82. Now we know from the central limit theorem The central limit theorem states that if I take enough numbers over and over and over, and these are like samples, then I can use, is going to approach normal. So I'm going to use my normal CDF. Turn my fancy calculator on. And my normal CDF, again, I'm going to make a little graph here. Make a little graph. I know on average, when I come in, I can multiply the averages, or I can add them up 30 times. So I'm going to pay, on average, 47 cents times 30. So 47 cents times 30 is $14. Now that's for 30 different videos, so that's pretty cheap. So $14.01. How did I calculate that? That's $47 times 30. So that's what I'm going to expect. So my normal CDF would state that I'm looking for the probability of exceeding 15. So this is a number, 15, that more than that. So on average, I would spend at 30 visits. This, more than that, would then be, the lower bound is 15. The upper bound is a super big number. Mu is this, and the standard deviation is that. So again, when I type it in my fancy calculator, which I'll write it out for you, norm CDF, 15 is my lower bound. A really big number is my upper, 14.1 is my mu, and 0.82 is my standard deviation. When I hit enter, that's when I get my answer that I would round to 14%. Thanks for joining.